Good morning, students. I'm Professor Priya Sharma, PCG Department, SIRT College, Bhopal. Sejanandam. So this is our 11th lecture of the lecture series, Digital Circuit System subject, which we are going through. The 11th lecture will cover the digital to analog converters. So what is digital to analog converters? A digital to analog converter takes a digital code as its input and produces an analog voltage or current as its output. This analog output is proportional to the digital input. This is the basic functionality of what a DAC do. The binary input is given to the DAC and it is converted to its equivalent analog output. Digital to analog conversion involves transforming the computer's binary outputs in zeros and ones into an analog representation of the binary data. A DAC will contain an and digital inputs for digital encoding, analog input of maximum voltage which will take and produces an analog output A. This is the basic block diagram having n binary inputs and producing an equivalent analog output. Coming to the applications of DAC, it is used as a circuit components in voltage controlled amplifier, digitally operated attenuators and programmable filters. It is also used in digital audios like in mobile phones. It is also used in function generators. There are two types of DAC, binary weighted resistor and R2R ladder. Coming to the binary weighted resistor DACs, it utilizes an inverting weighted op-amp circuit. Why it is being stated inverting? Because it is the resistor network is connected to the negative terminal of the op-amp. That's why it is termed as inverting. The weighted resistors are used to distinguish each bit from the MSB to the LSB. The leftmost bit is the MSB and the rightmost bit is the LSB. It is a switching network. If the switch of the particular resistor is connected to minus V reference, that implies that it is having a binary input of 1, and if it is connected to the ground, then it implies that the input is 0 or low. The weights of the resistors are being decided using the powers of 2, like 2 ki power 0 r, 2 ki power 1 r, 2 ki power 2 r, and 2 ki power 3 r, and so on, depending on the number of bit resistor it is being used. This is a simple example of how we convert this. You can see all the switches are connected to the V reference. That means all the inputs are 1, which is equivalent to 15 of an analog output. Questions can be asked regarding these. So how to solve these? Basically, this either diagram is given or all the inputs are given and we have to calculate the output, equivalent output voltage. So this is the binary input which is given. Topmost is the MSB, lowermost is the LSB. This is the equivalent resistors weights. This is the feedback resistor. This is the ground resistor, and we have to calculate this output voltage. So from the Ohm's law, it is clear that V out is equals to minus IR. I can be written as V by R. So taking the RF as common, it is V1 by R plus V2 upon 2R plus V3 upon 4R plus V4 upon 8R. So R reference is 10K upon the first resistor 1.25K into the first bit voltage is 1. Then 10K upon 2.5K into 1. Then 10K upon 5K into 0. Then 10K upon 10K into 1. This comes after solving this, it comes out to be minus 13 volts. So our answer is minus 13 volts. This is how we can solve the questions of a DAC. Coming to the advantages and disadvantages. Advantages is it's a simple analysis. It's fast. Conversion is very fast. Disadvantage is that this setup requires a wide range of accurate value of resistors. A 10-bit DAC needs resistors ranging from R to R upon 1024. Requires low switch resistances in transistors, usually limited to 8-bit resolution. The major disadvantage of a binary weighted resistor is as the number of bits increases in the input, then the weights of the resistors also increases, which makes the numerical portion very difficult. To overcome from this limitation, we have used R2R ladder. In R2R ladder, only we can see the two weights of the resistors as 2. Only R and 2R resistors are present. Even if we increase the number of bits, then also we will use only R and 2R ladders, R and 2R resistors, which will not become complex for solving or calculating the output voltage. So each bit over here also corresponds to a switch. If it is connected to 1, that means all the switches will be connected to V reference if the input is 1. And if it is connected to ground, replies that the input is 0. So the bit is high, when the inputs when the resistors are connected to the switch, or the switch is connected to V reference and the bit is low, then the switches are connected to the ground. This is a more easy or solved portion of the same circuit diagram, and the current depends on the bit positions, and the current is divided by a factor of 2 at each node. Now the advantages of R2R ladder is it uses only two resistor values, R into R. It does not require high precision resistors. The only disadvantage is low, its speed is low, conversion speed is low as compared to binary weighted digital to analog converters. So that's all for the digital to analog converters. I hope so it is clear. It is very easy. And in case of any query, you can contact me. So work very hard. All the very best students. Thank you. Sej Anandam.